Hello, Assalamu alaikum everyone. Today we will discuss latest ES level chemistry paper, May June 2024, and its variant is 21. So it is the latest paper. So today we are going to solve this. Okay, continue. So we have question number one. The elements of group 17 are called halogens, and complete the table. Table 1.1 is given, and we have to write their colors. You know, it is mentioned in 293, and if you convert 293 degree into Celsius, understood, it is approximately room temperature. So just this is a low order question, very simple question. You have to write their colors. You know, chlorine is found as a yellow green at room temperature. It is yellow green. And what about bromine? It is in a liquid state, and orange red, or you can say it's a like orange red color at room temperature. State is like chlorine is a gas, bromine is a liquid, okay, and you know iodine is a solid. No need to explain these physical states, and you know its color is grayish or grayish black. You can write it, okay, gray or grayish black. So very simple question for 1 mark. So state the trend in volatility of the halogens chlorine, bromine, and iodine. So you know what is the volatile? Volatile means when something easily evaporate, okay, at room temperature, okay. So we know like chlorine is a gas, bromine is a liquid, and iodine is a solid. So we can easily understand this like volatile is decreasing down the group, because you know for chlorine, because it is gas, it is easy to volatile. Bromine is the liquid. So you will write the answer volatility of of halogens decrease. Understand? So it is actually decreasing down the group. So now he is asking explain your answer. So you have to give reasons why their volatility is decreasing down the group. So you can easily write it, you know, when you're going down, the size of an atom increases down the group, okay? When we move down in a group, you know, the size of atom increases. So you can say the first, you can say size increases, okay? According to your book, you can say number of electrons also increasing down the group, okay? So you know when it is going big, when you're going down, the size is increasing. You know the strength of van der Waals forces is also increasing. Okay, so you can write it here. So strength of van der Waals forces, they are also increasing down the group. Okay, so this could be the some reasons for your answer. So next question is iodine is made by reacting bromine with sodium iodide. Constant and ionic equation. Okay, you have to explain their ionic equation for reaction of bromine with sodium iodide. You know this question related to displacement reaction. This question came from the concept displacement reaction. And what is displacement reaction in halogens? You know, fluorine, chlorine, bromine, iodine. Okay, the above one element can displace its lower one. Okay, for example, you are having bromine reaction with sodium iodide. We are having bromine Br2 reaction with sodium iodide. It is NaI. Okay, so you know bromine is above, then iodine. So bromine easily can displace iodine. So now bromine will displace iodine. It will become sodium bromide, NaBr. So you will get this iodine. You know group 7 is a like diatomic molecules. They exist in diatomic form. So you have to write iodine in diatomic form. Now you have to write this ionic equation. Okay. So how to write there like in ionic form? So now it is, you can say it is a positive ion. Sodium is positive ion, iodine will be negative ion, and it is a bromine because it is only diatomic covalent molecule, so you cannot convert that into ions. Okay, so here you will make sodium positive ion and bromine group 7, they carry negative 1 charge, and iodine, because this is independent and is covalent in structure right now because iodine bonded with iodine. So when there's something covalent like this, you cannot convert them into its ions. Okay, so now sodium will cancel out with this sodium, so you will get your final equation. You will get Br2 with iodide ion. Okay, and you are converting into it bromide ion, plus you will get iodine. So you have to balance this equation. You have two bromines, you will put two here, and two iodine, you will put two here. It is our balanced chemical equation. Understand? Here the role of bromine in this reaction. You can see when something, any element, if it is written in independent form, its oxidation state will be 0. So here bromine is a 0, but here it is negative 1, and here it is sodium is positive 1. So from 0 to you are going down, like it is going to negative, it is being reduced. So when something is being reduced, it is oxidizing agent. So your bromine, it is working as oxidizing agent. Bromine is oxidizing agent. Oxidizing agent. How can you say it? Why bromine is oxidizing agent? You can say it is oxidizing this iodide ion. It is a negative charge, and from negative charge to it is converting into zero oxidation state. When any atom or any molecule, if it is written in independent without anything, so their oxidation charge will be 0. So now bromine is actually oxidizing it. Okay, from negative to 0, it is being oxidized. Understand? So you can write it, iodide is losing electrons. It is losing electrons. Understand? And bromine is gaining that electron. Bromine is gaining electrons. Okay, so overall reaction is redox. So your answer is bromine is act as an oxidizing agent. Why? Because iodide ion, it is losing electron, and bromine molecule, it is gaining that electrons, okay, and converting into bromide negative ion. So next question is, concentrated sulfuric acid is added to separate samples containing equal amount of NaCl. You are having 3 beakers, number 1, number 2, and number 3. In this you have NaCl. In this you have NaBr, sodium bromide, and here you have sodium iodide. And you are adding sulfuric acid, H2SO4, into it, then into it, and same thing, you are adding sulfuric acid in all. Okay? Write an equation to describe the acid-base reaction that occur when concentrated sulfuric acid reacts with NaBr. So you can write it here, sodium bromide, NaBr. It is reacting with sulfuric acid, H2SO4. Understand? So in acid-base reaction, our hydrogen, it will displace this metal. I think you studied this in your O levels. Okay, so this sodium is more reactive than hydrogen. So this sodium, it will displace hydrogen from here. So then you will get this sodium sulfate, NaSO4, and you will get this hydrogen will react with this Br. This hydrogen will combine with the Br. You will get hydrogen bromide. Just you need to balance the equation. You have to apply 2 here, and because Na2SO4, so you need to apply 2 here. Okay, so sorry, my bad, you will put 2 here. Okay, so it is 2 NaBr at 2SO4, so it is an acid-base reaction. Deduce which sodium halide, NaCl, NaBr, produces the largest yield of hydrogen halide when concentrated sulfuric acid is added. So I2SO4 is the oxidizing agent in chemistry. we use sulfuric acid as act as oxidizing agent. Okay, and identity of the sodium halide, which one? Like fluorine is a strong oxidizing agent. Chlorine is less than fluorine oxidizing agent. Fluorine, chlorine, bromine, and iodine. They are strong oxidizing agents. Sulfuric acid is also a strong oxidizing agent. Understand? Sulfuric acid is also strong oxidizing agent. So the reaction with chlorine, because it is also chlorine, so you will get NaCl. Understand? The largest percentage yield of hydrogen halide, because rest of the things they will not produce hydrogen halide. So you can write it here, because chlorine is, if it is strong oxidizing agent, you will write it chlorine is weak weaker reducing agent. If it is strong oxidizing agent, you will write it is weaker reducing agent. Okay, chlorine as compared to bromine and iodine. Okay, it is the reason it is making more hydrogen halide. So the next question is, sulfur chloride is a liquid at room temperature. When acid is added to water, misty fumes are seen and solution is made that turns universal soap. Number one hint is misty fumes. So students, is my advice for everyone, please go through your original textbook. This information is mentioned in your textbook. Majority of students I have seen, they only follow past papers and notes. You people should go additional, actual Cambridge recommended book. Okay, chemistry, the third edition one. I will give the link in my description. You can download it from here. Okay. So first hint is we are getting misty fumes, and second is the universal indicator becomes red. If something is an acid, so then acid turns your indicator into red. So now you have HCl2, and now you have to react HCl2 with your water molecule. Okay. So identify the type of reaction that occurs when HCl2 is added to water. When something react with water, there are two type of reaction. What is the hydration? But there is no any double bond. So it is not hydration, because it is simple SCl and Cl. Sulfur is group 6 member. Oxygen, sulfur, selenium, tellurium, and polonium. It is from group 6. Okay. So group 6, they will have 6 electron in the valence shell. So 1, 2, 3, 4, 5, and 6. So you will have lone pairs. There's no in double bond. So when you add water, it is addition. But it is not addition, because there's no double bond. So it is hydrolysis. It is hydrolysis. If there is some double bond and water is being added with the expenditure of that double bond, that it will be hydration, but it is not hydration, because there is no any double bond. Okay, name a chloride of a different period 3 element that is also called liquid at room temperature and produces misty fumes. Once again, misty fumes, added to water. Period number 3, which elements of period number 3? Sodium, period number 3, magnesium, period number 3. You can take help from your periodic table, aluminum and silicon. So he is asking typical about silicon. Okay, so when silicon, silicon tetrachloride, when it react with water, okay, so then we get silicon hydroxide, and plus we will get HCl. This equation is mentioned in your textbook. Please follow your textbook. So HCl is a gas and it gives misty fumes. Okay, it gives misty fume because it is insoluble in water and when you will open the lid, HCl will start escaping. So then you will see the misty fumes. Understand? So name a chloride. So what is your chloride? SiCl4. Okay, silicon. When SiCl4, just you have to write the name of a chloride. No need to mention this like this formula. Okay, you will write just its name. Silicon tetrachloride. Okay, silicon tetrachloride. Silicon tetrachloride, because he is asking the name. Okay, it is your answer. And in equation you have seen how HCl, which is the responsible for misty fumes, is being formed. Complete the dot and cross structure. Okay, and you have to use cross to show electrons for chlorine atoms. Okay, you know chlorine is group 7. Chlorine is the member of group 7. Chlorine and bromine. Okay, it means each member is having 7 electrons. 1, 2, 3, 4, 5, 6, and 7 electrons in the valence shell, and they can make only one bond. The group 7, they carry negative 1 charge because they can only gain 1 electron. Okay, they can gain only 1 electron. So I will mention here 1, 2, 3, 4, 5. Okay, draw these in the form of pairs. Okay, draw these electrons in the form of pairs. Understand? So this is this last electron group 7. Here another chlorine 1, 2, 3, 4, 5, 6, and it is the 7th electron. So I already explained you sulfur is from group 6, oxygen, sulfur, selenium, and tellurium, so on. So they have 6 electrons in their valence shell. 1, 2, 3, 4, 5, and 6. You know, chlorine can make one bond, so it is the electron of the sulfur. It is another electron of the sulfur. So two electrons being shared with the each chlorine atom. So remaining you will have one lone pair of electrons here and one lone pair of electron here. Is it? So it is the structure of your SCl2, linear structure, not linear. We will see it. Predict the shape of bond angle in a molecule of SCl2. You people know, just like in water. For example, you have this water molecule. One of the lone pair is here and the lone pair is here. It is a V shape or bent. Okay, just like this, you can see you have sulfur with these two lone pairs of electron, and you can see one of the chlorine is here and other chlorine is here. You know these lone pairs, they occupy more space. When they occupy more space, they repel these bond pairs. So these lone pairs, they are repelling these bond pairs. Understand? So you can say their shape is bent. They are bent shape. Okay. Even you can write they are making V shape. V. You can. They are V shape. So you know what is the bond angle in water? In water has 104. I think so. 104.5. And same thing will be here. 104.5 degree. So you will write the bond angle 104.5 degree. Understood? So next is solid magnesium nitrite is a crystalline solid. Reduce the oxidation number. What is oxidation number? Apparent charge on an atom or a molecule. For example, magnesium is group 2. So apparent charge. For example, group 2 member, you can write it is positive 2 charge. Okay. So you know nitrogen is from group 5. It has 5 electron in the valence shell, and group 5 their charge is negative 3. Understood? This is the oxidation number. It is also called oxidation state. Apparent charge on an atom, you can say it is oxidation number. So now we are given Mg3 and 2. So how to find it? So first is we will find it for this nitrogen. Is it? So you know two nitrogens are there and 2. Okay. So you can write it 2x. X mean unknown value because nitrogen is our x. We have to find its charge. Plus, you know, one magnesium is carrying charge positive 2 and there are 3 magnesium. So multiply with 3. Because it is a neutral molecule, as a whole it is a neutral molecule, there is no any charge, it will become equal to 0. So 2x, we have to find this 2x, it will become equal to, देखो 3 2s are 6 and this 6 they will move here. So positive value will become negative. It will become negative 6. 3 2s are positive 6. But when you will move this towards this side, it will become negative 6. Okay. So your x will become negative 6 over 2. So your answer of x will be negative 3. So it means the charge on nitrogen is negative 3. So now we are going to find the charge on the magnesium, and we have like 3 magnesiums, so you will write 3x. 3x means there are 3 magnesiums, okay, minus 1 nitrogen charge is 3, okay, because 1 nitrogen charge is 3. So we have 2 nitrogens, so I will multiply with 2 equal to 0 because overall molecule is a neutral molecule, okay. So 3x, it will become equal to, so 3 multiplied by 2 6, negative 6, but when it will move there it will become positive 6, okay. When you will bring the value over this side it will become positive 6, understand. So now your x will be 6 divided by 3 and your x will be 2, positive 2. It means magnesium charge is positive 2. Very simple. I hope you understand this question. Next is magnesium nitride reacts with an excess of water to produce ammonia and magnesium hydroxide only. Construct an equation. So information is given. So why he is asking this type of question? Actual thing is examiner wants a balanced chemical equation, okay? Like everything is given, but why he is giving this question? He is checking your balancing skills. So you have Mg3 N2 magnesium nitride reacts with water, and he is telling you what are the products, ammonia and magnesium hydro. So one of the product is ammonia gas and other thing is magnesium hydroxide. You know magnesium is group 2 member, hydroxide overall carry negative 1 charge, so you have to put it here 2, okay. So 3 magnesiums are here, so you have to put 3 magnesiums here, okay. So next is hydrogens, if you put 2 here, so 3 2s are 6, because why I put it 2 here? Because you have 2 nitrogens. For balancing 2 nitrogens, I put it here 2 for nitrogen. So hydrogen will become 3 2s are 6. So I will become 3 2s are 6, and it is also hydrogen 2 and this 6, okay. So you will become 12. So I will put 6 here. Understand? So they want your balancing equation. Why the solution produced in this reaction has a pH greater than 7? When something is 7, it means that thing is a neutral, but greater than 7, it means it is basic in nature or alkaline in nature. Okay, when something is greater than 7, it means it is alkaline or basic in nature. So reason is clear, ammonia is a base because it has a lone pair of electrons, and magnesium hydroxide, it is also a base, okay. So magnesium hydroxide, it is producing hydroxide ions. It is the reason it is a base. And other thing, because ammonia gas, ammonia, it is also a base because it's carry lone pair of electron, okay. It is also an alkaline. So it is the reason you are getting pH greater than 7. So anything which is a base must possess lone pair of electron. You can see it here as well. It has lone pair of electron. It has lone pair of electron, because when any acid will react with this lone pair of electron, it will extract this hydrogen proton, okay. Boron nitride is a white solid that melts at above 229, is a very high temperature. So only two things have, if number one, if something is ionic, it means it has a high melting and boiling point. If something is giant covalent, okay, if something is giant covalent, then it can have high melting and boiling point. So now it has 29, boron nitride, boron. So ionic mean when something is metal and non-metal, boron is non-metal, it is non-metal, and nitrogen also a non-metal. So it means it is wrong and this concept is right because boron is non-metal, nitride is non-metal. So the bond between two non-metals, this is covalent in nature, and you can see in the diagram it is joint in structure. Okay, so what's the question? Deduce the empirical formula of boron nitride. So you can see, you can take any one layer of this compound. It is the one layer. In this one layer, for example, it is like this. This is the one sheet, one layer, and you can see it is bubble like this, and this one is filled, and this one is filled. Okay, with this you have atoms, and one atom is 1, 2, and 3. Okay, so you have three nitrogens like N3, you have three nitrogens, and you have three borons. Okay, B3 and 3. Understand? So each layer has three borons and three nitrogens. It is representing in your paper for nitrogen, and this thing is representing for boron. It is a molecular formula, the formula which gives us actual number of atoms. It is telling you there are three atoms of boron and three. It is molecular formula. But he is asking empirical one. B3 and 3, when the ratio is 3 ratio 1, 3 ratio 3. So empirical tells you simplest whole number ratio of atoms. So when you will simplify, it will become 1 1. So your formula will become Bn. Empirical formula will become the formula which gives us simplest whole number ratio of atoms of a molecule. What is the molecular formula? In molecular formula, actual number of atoms are mentioned. Okay. Suggest the identity of another crystalline solid that has atoms ring and layers. That solid, graphite. In graphite, you have carbons. All are carbons like this. The structure of graphite. It is also a joint covalent structure, and this bond is a weak bond with another layer. You can draw another layer with carbon, carbon, and carbon like this. Okay. Oh, my bad. So you can draw this type of shape in graphite. Okay, so your answer is graphite because both have giant covalent sheets like structure. They are different sheets. Graphite. Okay, the giant covalent structure. Next we have define Le Chatelier's principle. So now we are moving towards the chemical equilibrium. It is a very famous. Equilibrium will respond to a stress by countering its effect. When some reaction is in equilibrium, A plus B, and if you try to apply some stress mean if you change this temperature, concentration, or pressure, so equilibrium try to like adjust itself. So equilibrium will, so how to define it? Equilibrium will respond, equilibrium will respond to a stress, okay, by nullifying or by countering, okay, by countering, okay, by countering its effect. Understand? So what is the meaning of stress? What are you applying on this chemical equation? Stress means change in concentration. Stress means you are actually changing its concentration. Either you are changing its applying some pressure, either you are applying some temperature. So students, you have to follow your textbook for this type of definitions, and you have to like understand, like memorize, learn by heart the definitions of such question. Okay, it is an overall idea, but you people have to memorize it from your marking scheme or from your textbook. Reaction 1 describe the reversible reaction between yellow Fe3 positive and colorless SCN thionyl like cyanide to produce red FeSCN2. Okay, it is equation and reaction 1 mole and 1 mole. So ratio is same. They have same ratio 1 ratio 1 ratio 1. Understood? Any other clue from the okay? This value is given in negative. Negative value mean it is some exothermic reaction. Understood? This is a clue for us because the value is given in negative. So it means it is some exothermic reaction. A mixture of FeCN3 and SCN is at equilibrium at 20 degree. Understood? Temperature is mentioned at 20 degree. The temperature of the mixture is then increased to 50 and allowed to reach equilibrium. Deduce the change that occur if any. Equilibrium mixture is 50. You know temperature is being increased. Our initial T1 is 20 degree Celsius and T2 second temperature increases 50 degree. Understand? So when something is exothermic, if reaction is exothermic, if you increase the temperature, so your equilibrium shift to the left hand side. Okay, if temperature is already exothermic and you are increasing the temperature, so by increasing the temperature, your equilibrium will shift to the left hand side. So left hand side, one of the thing is your colorless, but other thing is yellow. It means if your equilibrium is shifting left hand side, it means more yellow color will be observed. Okay, so change in appearance will more yellow color will observed. More yellow like yellow color, sorry, COLOUR color formed. Okay, because by increasing the temperature your equilibrium will shift to the left and right hand side has red color but we are going to left hand side yellow color. Change in relative concentration of Fe and Sin2. You know when you are going back, when you are moving back, it means concentration of FeCN3 decreases. It is a common sense. When your equilibrium is shifting to the left hand side, it means the change in concentration will decrease. Okay, because it is shifting to the left hand side, so relative concentration of SN it will decrease. Okay, it will decrease. Understand? Change in value of the equilibrium constant. What is equilibrium constant? When products are given, so it is the ratio of products concentration to reactants concentration. Okay, so you can see your product is decreasing in this reaction. This is your product and this side is your reactant. So you can see the reactant is increasing, your reactant is increasing because it is going back. So your product is decreasing. Understand? So when your product is decreasing, you can see Kc is directly proportional to the product. So when product is decreasing, so Kc is also decreased. Kc is decreasing because product is decreasing. Understand? In another experiment, equimolar amount of iron 3 positive and SC negative are mixed together and allowed to reach equilibrium. Okay. The total volume of the mixture is 25 centimeter cube. So volume is given here and now at equilibrium mixture calculate the initial amount. Okay. So now we have to find their initial amounts. So you have to know this volume. It is given in 25 centimeter cube. Okay. So you know everything given is 1:1. It is 1 and it is also 1 and you can see it is also 1 mole. Okay. If you find the like moles of 1 you can easily predict the number. So concentration is given. Something in chemistry, if something is in bracket, bracket means concentration. Okay. Bracket mean concentration, that is equal to moles over volume. So 8 mole volume is given in decimeter cube. We use this volume in decimeter cube. So something in chemistry, if something is written in bracket, it means it is concentration, and C is equal to moles per volume in decimeter cube. So you can write mole per dm cube. It means their concentrations are given. So now try to solve this question. Here we have reactants, they have same ratio. Understood? So if we have SCN concentration negative, okay, it is about one of the reactant, it will become equal to concentration of Fe 3 positive, because both are 1 to 1, okay, minus concentration of FeCN negative 2 positive. Understand? It will start disappear because it is a reactant. When reactant disappear, your product appear. Understand? Even you can say, because they have 1 so it will like start consuming. If it is start consumed, it will form. Okay, so when reactant start disappear, your product start appear. In other sense, you can say when reactant start consumed, your product will start form. Okay, so we need to find this Fe. If I bring this value this side, it will become positive. So your Fe will become Fe 3 positive. Its concentration, it will become like SCN. You can write it SCN negative. Okay, negative, this negative value, when it will transfer here, it will become positive, and you will get this FeCN positive 2. So now put their values. Let me put, so SCN is given here 1.30, 1.30 into 10 to power minus 3 plus FeSCN is given 0.300, it is 0.300 into 10 to power minus 3. Understand? So let me calculate it. So it is becoming 1.6 into 10 to power minus 3 mole per dm cube, mole per dm cube, because it is concentration. I already told you it is in bracket, it is the concentration of this iron. Okay, so the thing is you have to find their moles. Okay, so you have two things you can find moles. One method is by using number of moles is equal to volume into concentration. So now we need to find the number of moles. So volume is given, that is our question. You can see volume is 25, but it is centimeter cube. So first centimeter cube divided by 1000. Okay, you will get answer in decimeter cube. Understand? So how to convert this? N is equal to V multiplied by C. So volume is 25. Divide by 25 with 1000 because you need to convert it to decimeter. Why? Each concentration is given in decimeter cube. Understand? So multiply with concentration. So what is our concentration? Answer is 1.6 into 10 to power minus 3. Understand? So your answer should be equal to 4.0 into 10 to power minus 5 moles. Understand? It is our answer. I hope you understand this question. Calculate Kc for reaction when and states its unit. Okay. Reaction 1. So everything is given in 1:1. Okay. So how to write Kc expression? Kc is equal to concentration of products over concentration of reactants. So bracket mean concentration of product. So what is our product in that reaction? FeSCN. Okay, it is the product. You can write 2 positive the charge here. So you have 2 reactants. So concentration of Fe positive 3 and the concentration of SCN negative. Okay, bracket mean the concentration. So you have to find its value. Okay, so what we got for Kc? what we got the answer? That was actually 0.300, okay, multiply with 10 to power minus 3 divided by, they are same Fe positive 3 SCN both have 1 ratio, okay. So if one has 1.3 into 10 to power minus 3, because it is given, you can see it here, this is 1.3 into 10 to the power minus 3, okay, because the both molar ratio is 1 1. So I will write multiply with 1.3 for this SCN, for this 1.3 into 10 to the power minus 3. Just use your calculator and find this answer. So your KC should be equal to 177.5. Other thing is you have to find its units. You know, when something here, its unit will be mole per dm cube, mole per dm cube divided by, unit for this, it is also mole per dm cube. Understand? Multiply with unit for this SCN, moles per dm cube. Okay? So now you know, your teacher might be told you, so this mole per dm cube cancel with this mole per dm cube. Understand? So denominator will cancel out with one of the denominator, and you will get this value again. It will become 1 over mole dm cube. Understand? But when you will bring it up, you will get mole inverse 1, and it is the negative 3 dm cube, it will become positive 3. It is your answer, mole negative 1 inverse 1 and dm cube is positive, okay. It is your answer. Define enthalpy change of formation. Enthalpy change of formation is, for example, if you have something, formation means 1 mole of, okay, you are making a compound that must be equal to 1 mole. For example, carbon combined with oxygen, okay, and you are making 1 mole of CO2. And these reactants, they must be in their standard physical state. For example, carbon exists in solid form, oxygen exists in gaseous form, and CO2 will get in gaseous form, okay. So you will write it here, energy change, or you can say it enthalpy change, okay. Enthalpy change, when 1 mole of enthalpy change, enthalpy change when 1 mole of a compound is formed from its element, from its elements in their standard physical states, okay, in their standard, in their standard states, physical states. Physical I'm writing to just express, like carbon is solid form exists, oxygen in O2 form exists in O2, okay. At room temperature and pressure, even you can say at standard condition, at under standard conditions, okay, the standard conditions. So I already told you, you people have to memorize such definitions from your textbook, okay. I will give the link of this textbook in my description, you can download it from here. So next reaction is iron is made when one oxide is heated with carbon monoxide. So you have to write as oxygen. You know, I told you an equation. For example, you are making iron oxide, Fe2O3, Fe2O3, okay. You know, when iron will burn or will combine with oxygen O2 because oxygen exists in nature as O2. Okay, so you will get this Fe2O3. So you need to balance this equation. There are two iron, so you will put it here too. Understand? So oxygen is O3. So you can simply put either 1.5, you can write it either 3 by 2. Okay, 2 cancel with this 2, you will get 3, and here is another 3. Okay, so you are making carbon monoxide. When carbon, so you can write it exists in a solid form and it exists in a gaseous form. Okay, so you will get this solid Fe2O3. So now you are making carbon monoxide. Carbon monoxide is a gas. 1 mole is product. It is also 1 mole. So you will write the equation when a carbon reacts with O2, you will get carbon monoxide. But carbon in solid form, oxygen in gaseous form. So it's a one oxygen is here. So I will write mention 1/2, half molecule. Okay, not half atom. It is half of the molecule. Okay. So third equation is given with their values, and it is not. It means standard values. Does not mean things are mentioned in their standard values. Okay. Compare table 4.1 by adding equations with relevant state symbols. Okay, I already mentioned state symbols. Standard enthalpy change of formation Fe2O3 and standard enthalpy change formation of CO. Okay, use the data to calculate the enthalpy change of reaction in kilojoules mole for your reaction. Okay, so we have to find the total reaction. If you follow your textbook, so how to find it? Here you will write the reactants. I will write here reactants, arrow. I will write here products. This thing is mentioned in your textbook. And here I will write their elements. Understand? Okay. When elements combine together, you will get the reactant. When these things combine together, you will get again the product. Okay. So it is in your book, don't you worry. So let me explain this. You are having Fe2O3, Fe2O3. Okay, it is reaction with 3 moles of carbon monoxide, and you are getting iron 2Fe plus you are getting 3 moles of CO2. Okay, so let me remove this from here. It is just for your idea. Okay, so now I will write these elements in their elements form. I will put elements here. So we have carbon element, then we have oxygen, and we have iron. Okay, you have oxygen and you have iron. Here you can see you have oxygen, you have carbon, you have oxygen, and you have iron. Okay, so carbon exists in their solid form, oxygen exists in O2 in gaseous form, and iron exists as Fe. Okay, so how many carbons are there? 3. So you will put it here 3. You will write oxygen, so you need to balance the oxygen. How to write it? You can say 3O, like it is 3O and 3 6, so you will write 3O2 because 3 oxygen and 3 is multiplied with this oxygen, 6 oxygen, 3 to the 6. And how many ions are there? 2. I will write it here 2. So it is less like elements. Okay, so these elements combined together, they will make these things. Understand? And when they will combine together, you will get also this thing. It is for reactants. Sorry for back noise. Okay, so your reactants, products, so it is your Hazel's law time. Okay, so now you can see these things are combining together. So it is making just that these things combined together give reactants, and reactant gives product. So it is clockwise. Arrow is in clockwise direction. So when your arrow is in clockwise direction, now apply these values. Fe2O3 formation is given. It is minus 824.2. Okay. And other for CO, it is given minus 110. minus 110.5. Because we're using 3 moles of carbon monoxide, so I am multiplying it with 3. Understand? So what about the right hand side? Carbon, here it is. So you know Fe, like 2Fe, independent value. So that's why its value is not given. Okay. So you have to write it here. It's minus 393. Minus 393. Okay. 0.5. So let me check it there. So you have 3. So you will multiply with 3 because value is 3 there. It is 3. So you will multiply with this 3. So now you have to put their values and you will get their answer. So let me remove this helping triangle for you. Let me remove it. It might take a time. You can skip this thing, okay? So now I'm separating this area. So now let me, because I told you it is in clockwise, so I will put this value in positive, okay? So go and study your book, you will need to study there when something is making clockwise. So because these things are combining together, okay? So these values will become positive. So delta H, it is your delta H not because it is in standard conditions for reaction. So delta H change in enthalpy for or for reaction, it is not for standard values. Okay, so it is, you can say it. Now apply this all these values. Okay, so it is positive and it is minus 824 824.2. So use calculator carefully, this 3. Okay, and next plus you have minus 110.5. Okay, multiply by 3. Multiply by 3 minus you have minus 393.5 multiply by 3. If something is in this side, you will use the negative. If it is making clockwise direction, this area you will use positive value and this area you will use negative. So I added here negative minus 390, the 393.5 multiplied by 3. Understand? Equal to 0. Equal to 0 because we are finding the overall reaction. Okay. So delta H R hyphen, like it is making standard values, minus 824.3 minus, so when this thing multiply with 3, okay, 110.5 multiply with 3, you will get 331.5 plus negative negative, this value negative and negative, it will become positive and it will become 1180.5 equal to 0. Okay, so now delta HR, we are just solving each step again and again. Delta HR minus 115.1155, okay, 0.8 plus, now I'm solving it, plus 1180 equal to 0. Okay, you have one option. If you bring all this value towards the 0 side, you can do it in this sense. So delta H of reaction, it will become minus 24.7, unit is kilojoule per mole. Okay, if you bring all these values, understand, towards here, you know your sign will change, and then if you add them together, you will get delta H of reaction minus 24.7 kilojoule per mole. Okay, it is our another question we have done successfully. So we are moving towards the next slide. Understand? So you will write it here negative 24.7. Hydrocarbon molecules contain covalent bond. Define covalent bond. Very simple, bond formed by mutual sharing of electrons. Okay, bond formed by mutual sharing of electrons. Okay, Next is a carbon-carbon double bond in an alkene is made from a sigma bond and a pi bond. Identify the hybridization of the carbon atom in a carbon. You know, when there's a double bond in carbon, okay? For example, you have carbon to carbon double bond. This connected with the hydrogen, hydrogen, and hydrogen. When a carbon connected with three things, for example, you can see it's a carbon A. It is connected with one hydrogen, number two another hydrogen, and number three it is connected with this carbon. You can see this A carbon, it is connected with three things. When a carbon either making double bond or if it is connected with three other things, so their hybridization state will be sp2. Okay, the hybridization will be sp2 hybridized. Okay, so carbon to carbon double bond is there. So when a carbon is connected with three other things, you can see this A, it is connected with one hydrogen bond, 1, 2, and this carbon, three things, it is sp2. Draw a label diagram to show in terms of orbital overlap how the sigma bond and pi bonds are made. You know, sigma bond, the first bond is always a sigma bond. You can see it is a carbon, the sp2. sp2 means 1s and px and py and pz. Understand? So sp2 means when 1s and 2p, 1s and 2p. So they are actually overlapping, they are actually hybridizing, and they are making three hybrid orbitals, 1, 2, and 3. So what about this pz? It is unhybrid, it is not hybridized. So first point is your pi bond is formed by unhybrid orbital. So now you have three hybrid orbitals. So you know carbon carbon, carbon to carbon. Okay. So when they are joined together head on head, it is this bond is formed sigma bond. Okay. It is made by sigma bond. And what about pi? Now you can see this each carbon unhybrid PZ. I'm labeling it unhybridized PZ. Okay, each carbon contain unhybridized PZ orbitals. Okay, so pi bond will form when these two PZ unhybrid and this PZ here you can draw them here like this, like PZ and PZ when this side to side overlap. Okay, yeah, parallel overlapping or side to side, they are making a pi bond. Okay, so you can explain them that. So this is the strong bond, and this pi bond is a weak. So just one difference between sigma and pi bond that explain why the pi bond is broken in electrophilic addition reactions involving alkene. Because it is a weak bond, pi bond is a pi is weak, is a weaker bond than sigma. Understand? So an electrophile easily attack on them. Electrophile easily approach. Okay, because the ROACH. Okay, so pi is a weaker bond because this side to side overlap. Okay, it is the reason. It is weak bond. Okay, complete. Show the mechanism for the electrophilic addition of hydrogen bromide to methyl propane. Okay, major organic product. Okay, so you know because of this pi bond, it is a pi bond and it is a sigma bond. You know, pi bond is a weak bond. Okay, and this pi bond will attack over this. You know, it is. Let me make it more thinner for this mechanism. Okay, so you can see it. See it. It is partial positive and it is partial negative. Okay, so here you know because of this pi electrons, it's a pi bond, electron density is higher. So these pi electrons they will attack over here, and hydrogen electron, bromine, they both will move with the bromine. Okay, So it is electrophilic addition reaction. Understand? So you will get what you will get. Number one, hydrogen, carbon, and hydrogen, and one of the pi bond is broken down. You will get Ca3, and you will get Ca3. Understand? So because this hydrogen is being attached, now I have two chances. If I attach hydrogen on this carbon, understand? So for example, it is the hydrogen, this one, okay, this hydrogen. If I attach hydrogen here, I will get carbocation on this carbon. So you know this carbon is further connected with this carbon, primary, this and this. So it is your tertiary carbocation. So you know tertiary carbocation is more stable. Another case is if I draw, just I am explaining you. For example, if I make this product, if I like draw this product, Ca3 and Ca3, okay. For example, if I attach this hydrogen here, it's a bold hydrogen, you can see. So you will get carbocation here. You know it is a primary carbocation. It is our primary carbocation, and it is tertiary carbocation. Okay, so he is actually asking the major organic product. So tertiary carbocation is more stable. This product is more, okay, major product, you can see this one. So you will write this mechanism. Let me remove this. This is our minor product. I'm removing it. Okay, so you will get this tertiary carbocation, our major product. Understand? So you will draw this. Okay, so let me write it again. Here, your Ca3. So you will get this. Now what will happen? It is your bromine negative with negative charge. So your negative charge will attack over this carbon. You will get CH3 with this carbon with this bromine, Ca3 and this Ca3. So this is our major product because this tertiary carbocation, because of this tertiary carbocation, okay. Understand? It is electrophilic addition reaction. We show stereoisomerism. Explain what is meant by stereoisomerism. You know the compounds having same chemical formula, organic compounds having, let me change the color, sorry, having same chemical formula, or sorry, molecular formula or chemical formula. But different arrangement of atoms in space. Different arrangement, but they have different arrangement of atoms in space. Stereoisomerism is related to three-dimensional. Your stereoisomerism, it deals with three-dimensional. So it is atom arrangement of atoms in space. Understand? So I explained you very well. Okay, the next we are moving. Reduce the number of stereoisomers of we explain your reasoning. Okay, you know, when we find stereoisomers, we need two things. Number of double bond, carbon to carbon double bond, okay? We need two things, carbon to carbon double bond, okay? Here you can see it is the carbon to carbon, one double bond is here, and number of chiral carbons. A chiral carbon, when a carbon is connected with four different groups. For example, if a carbon is connected with four different groups, not atoms, okay? For example, it is connected with four different groups. So this carbon is a chiral carbon. Understand? So we have to predict the chiral carbons. This it is the carbon number is one chiral carbon because it is connected with four different things. One, two, three, and fourth one is the hydrogen. Okay, same one, two, three, and four substances hydrogen. So you know what is the formula? If things are given to how to find their number of stereoisomers, so what is our formula? That is 2n. That is actually 2n. Okay. So there are how many chiral carbons are 2 and n is number 1. So you will write 2, n is equal to 3. Number of chiral carbons and number of carbon 2. Even this is double bond, but it is not carbon to carbon double bond. It is not carbon to carbon double bond. You will not include this. Okay. You will only talk about this carbon to carbon double bond. Okay. So there are two carbons, and you have one double bond. Okay. Double bond. So 2 plus 1 is equal to 3. So n value is 3. So you will get 8. 2 power 3 is 8. 8 means you will get 8 isomers. You will get there 8 isomers. Okay, so you have to include number of carbon to carbon double bonds. So you can write it here by 2 and 3 formula. There are two chiral carbons, the carbons which are connected with four different groups, carbons, and one double bond, one carbon to carbon double bond. Okay, carbon to carbon double bond. Okay, so when you will apply this formula, you will get 8 isomers. Okay, so next we have deduce the molecular formula, the formula which gives us the actual number of atoms, how many total number of atoms are there. Okay, so it is known as molecular formula. So now you have to find the actual number of atoms, how many number of carbons are there, number of hydrogens are there. Okay, so let me remove it first for you. Okay, so now first we will find number of carbons. You know it is carbon number 1, carbon number 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and it is 13. Okay, so you can write C13. Now you have to find number of hydrogen atoms. How many hydrogens are there? Okay, so you can see 3 hydrogens are there. 1, 2, 3, 4, 5. Okay, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16, 17, 18, 19, 20. So C is 13, H 20, oxygen 1, 2, and 3, O3. Okay, O capital 3. So C13, H20, O3. Molecular formula. What is the formula? C13, H20, O3. Okay. Name all the function group present in V. Oh, very simple. So now you have to find number of function groups. You can see it. It's really simple. You can see the very first one is carbon to carbon double bond. Okay. So what is carbon to carbon double bond? When you have carbon to carbon double bond, it is alkene. Okay. So you can see carbon to carbon double bond. It is an alkene. This is a carbonyl carbon. Carbon double bond with oxygen. When carbonyl carbon connected both sides with the carbon, it is known as a ketone function group. When you have this carbonyl group and this carbonyl group, both ends are connected with carbon, it is known as a ketone. And what about this is the famous one, ester linkage. Okay, so we have alkene. A is the alkene, B is a ketone, and C is our ester. C is our, it's our ester. Okay, so you can see we have alkene, you have ketone, and the third one we have ester. Understand? So we have three functional groups. Okay, show two reactions involving V, and the first reagent you are converting V into this. Okay, so first we have three function groups. One, ketone is the second, and ester is the third. So what is happening actually? This function group you are converting into alcohol. Okay, you know, when you reduce some ketone, if you have a ketone, if you reduce it, you will get secondary alcohol. Okay, if you reduce ketone, you will get secondary alcohol. You can see it's a secondary alcohol. Ester is unaffected, and double bond, it is also reduced. Okay, so what is the reaction one and reagent? You know, it is the reduction because you are reducing carbonyl group into alcohol. Okay, and it is alkene. Carbon to carbon double bond is alkene. It is converting into alkanate chain. Okay, alkane, A-N-E. So type of reaction is, it is actually reduction. It is a reduction reaction. And what is your reagent T? So you can see it is lithium aluminum hydride. It is a strong reducing agent. It is a strong reducing agent because it is reducing all functional groups except this. Okay, except ester. Strong reducing agent. Okay, so what is happening in 2? Reaction 2, it is reduced into alcohol, but your alkene is unaffected. In chemistry, it is known as selectivity. Selectivity means you want to destroy or you want to change one of the function group, but you are saving the other one. If you have like reactivity, selectivity, you are selecting the one function group. Okay, you want reduction of one function group, but you want to save the other one. You want to reduce reduction of this function group into this, but you want to save it. So then you will use a mediocre type of reducing agent. According to your syllabus, we will use, it is also a reduction, it is also a reduction. Okay, but we will use mild of reducing agent. We will use mild reducing agent. Okay, okay, mild reducing agent, and that is sodium borohydrate, Na, sodium borohydride. Okay, BH3 and BH4. Okay, so it is selectivity. You want to reduce it, but you want to save it. Okay, so then you will use sodium borohydride. Identify the role of T for each function group that reacts in reaction 1. It is the reducing agent. Okay, yes, you are. It is doing actually reducing agent. Okay, suggest the identify of reagent U in reaction 2. Identity. So it is the sodium borohydride, mild reducing agent. Sodium borohydride, mild reducing agent. Okay. Next, you have a question. Both function groups in one molecule of Y react with inorganic reagent to form one molecule of Q. Okay. So now we have to understand, we have to identify, okay, Q and one molecule of methanol. So now the question is, you have to figure out. So first thing is, uh, inorganic reagent we are using, and one of the product is methanol. You know, it is an ester. When a carboxylic acid, when a carboxylic acid react with alcohol is given, that is methanol, CI3OH. So you will get an ester. Okay. So opposite of this reaction, when you are breaking ester into its carboxylic acid and alcohol, It is known as hydrolysis. It is known as hydrolysis. It means you are breaking an ester into its basic components in your question. So one of the component is mentioned and that component is given your methanol. So suppose if I break this ester from here, so you know it is CH3, this area is CH3. I will get this CH3 with O, understand? And I will get this area, okay, this thing, I will get this OH, okay, plus I will put O here. It is your alcohol methanol and you will get carboxylic acid. So it is actually your reagent is water because you're doing hydrolysis. Inorganic reagent water because this reaction is hydrolysis of an ester. So you have to draw this Q. I'm good in drawing, so I can easily draw 5 carbon chains. Okay, and with double bond with O, ketone group with 1, 2, 3, 4, 5, and I will draw this 1, 2, double bond with oxygen, and here you have this OH. So your Q is actually a carboxylic acid. Okay, so now next is O. Okay, I am solving past papers for many years, so I never see such a question like this part 1. Part of the mass spectrum of Q is shown. Although it is in your book, but I think it is very first time this type of question. Part of the mass spectrum of Q is shown in figure 6.4, okay, and only peak with M over E greater than 198 are shown, okay. So these are peaks, they are greater than 198, 199, 200, 201, okay. So its relative abundance is 100%. So 100% is your total compound, you can say it. And the question is relative abundance of X, all the peaks at M over V is a 201, okay. So show your working. So first you need to find number of carbon atoms. You can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 9, 10, 11, and it is 12 carbons are there, okay. What about 13 one? It is from methanol. It is carbon number 13, like, okay, because it's broken down from here. Ester is breakdown, okay. So now you have to find its value and show your working. In your books, number of carbons, N is equal to number of carbons. 100%, and in 100%, 1.1% is carbon 13. That is making this, okay, this X. So this formula is given in your book, okay. So if it is given 100%, so you can write it, this substance there which is making 100%, it is your M positive peak, okay, which is used as molecular ion peak. You can explain it. It is your molecular ion peak. And what about this X? It is in your book. You can say it is M plus 1 peak. It is because of carbon 13. I think so. What is in my mind? You can check it, please. M plus 1 peak. Okay. So now you have to put their values in the formula, you know. In your book, it is given, I think, the concentration or the average of M plus 1 peak over M positive peak. Okay. So now you have to put their values. So number of carbons we calculated from the formula that are 12 equal to 100 over 1.1. So multiply by M plus 1, you have to find it. It is your X. M plus 1, you have to find this peak, okay. X over, what is the M positive? It is given, M is 100, okay. So when you will solve it, you will get the X value, that is, X is 13.2. So X is 13.2, okay. It is 13.2. This X is actually 13.2 and it is actually this carbon 13, okay. You can say it. Sheer methanol. Would be methanol. Q contains only hydroxyl functional groups. Okay. First one is, where is the Q? He is talking about this Here it is carbonyl group, but he is saying it has only hydroxyl groups. Okay, so read this question carefully. He is asking there's a, so first write is OH. Okay, because he is saying it contains only, okay, this type of this here. So it is our structure Q. Okay, hydroxyl groups. Complete table 6.1 to show the observation that occur when 2,4-dinitrophenyl hydrazine is added to separate. 2,4-hydrazine, this 2,4 Brand's reagent DNPH. It is used for detecting carbonyl group. If there is carbon double bond carbonyl group, it doesn't matter the substance is aldehyde or ketone. Okay, it doesn't matter. It detects both aldehyde and ketone. And you can see in your Y structure, you have this ketone function group, you have aldehyde group. So it will give positive test. Okay, it will give us positive test. So because the Y contain, so you will get yellow orange precipitate. What is the positive test? You will get yellow orange precipitate. Okay, because Y contain carbonyl group. Okay, but Q is only hydroxyl groups. You can see here there's no carbonyl, so no reaction. You can see no reaction or no PPT or no observation, no color change. Okay, it is important. Q only contains hydroxyl function groups, so you have to make it. Okay, consider it. Okay. Under certain conditions, 0.0020 mole of Q react with excess of sodium to produce a total 44.8. Okay, so now you have Q, OH, it is, and now it is, ONH, carboxylic and okay, Q, okay, 0.0020 moles. So its moles are given 0.0020 moles. Excess of sodium. So you are reacting with excess. You have sodium in excess. Okay, excess. So you will get the product. When an acid reaction, alcohol is a weak acid. Carboxylic acid is little bit stronger. It is stronger than alcohol. So when the reaction will happen, you will get salt, ONA, and O and Na positive. Okay, positive and negative. You will get this salt. Sodium is in excess. That's why it's reacting it here and here. Okay. So what is the thing? Question is given. It will produces 1 mole of hydrogen gas, because when an acid react with metal, this H and this H, okay, they're releasing as a hydrogen gas. So sodium to produce a total of 44.8 cm cube of gas. Its volume is given 44.8 centimeter cube. Understand? Calculate the number of hydroxyl groups present in a molecule. Okay. So you can see in the from the equation ratios everywhere 1:1. Okay. If 0 points, so first find the number of moles of this. So if conditions are STP, standard temperature and pressure. Okay. How to get the moles? So you will simply 44.8, because in centimeter cube. So you will divide it by 24,000. Okay. 24,000. When things are given in standard temperature and pressure, how to get the moles? Just simply, if you have that volume, you have two options. First, convert the volume into decimeter cube, then divide it with 24. But I am just dividing it with, so you will get the answer. Same again, I think it's 0.0020. So you can say both they have 1:1. Okay, 1:1. So you will have, if you're getting two hydrogens like two atoms, So you need two OH groups. Okay. So how many number of OH groups must be there? Two. Understand? So the next is use table 6.2 to describe a spin to difference between the infrared spectrum of Y and Q in the region. So now we are given the, I think it's the last question from IR region. So first you need to figure out what is happening in Y and what is in Q, sorry. So is there a double? Okay. Here you have carbonyl group and ester linkage, and there you have hydroxyl group. Okay. So first thing is, in your Y, in above molecule, if you have a Y molecule, you have carbon double bond oxygen, a ketone group. Okay. And what is the carbonyl value it is given? It is 1672 1740. It is 16702 1740. Understand? And what about your Q? Q is given with hydroxyl group. We studied it contains hydroxyl group instead of C double bond O. Okay? Understand? So Q you have OH group. And what is the value of this hydroxyl group? You can see it here. It is 32002 3650. 3200 2 it has 3650 peaks. Okay, I think this is the only answer. Okay, this Y it doesn't contain OH group. Okay, Y don't contain OH group. Okay, Y doesn't contain this, doesn't contain this. Okay, so I think your paper is over.